Hi friends, very good morning. Welcome to Anu Academy. Very good morning friends. Let us start today's class. Today's class, our subject is strength of materials. In this class, we are going to discuss strength of materials. In that, we will be discussing uh, deflection of a beam, conjugate beam, simply supported beam, okay, and torsion, centroid, springs. Okay, these things we will be discussing in today's class. So let us start today's class. Okay, right. Okay, material is ready. Now we will start discussing. If the actual beam has both ends fixed, then the ends of the conjugate beam will be free at both ends. The width of a conjugate beam is 1 by EI, 1 by E into I. With the help of a conjugate beam method, we can find out the slope in case of simply supported beams. We can find the deflection of a beam carrying uniformly distributed load, central point load, gradually varying load. Okay. A cantilever of span L is fixed at A and propped at the other end B if it is carrying a uniformly distributed load of W per unit length, then the prop reaction will be 3WL by 8. The deflection at the center of a propped cantilever of span L carrying a uniformly distributed load W per unit length is WL to the power 4 by 192 E into I. The maximum deflection of a propped cantilever of span L subjected to a uniformly distributed load of W per unit length will occur at a distance of 0.422 L from the propped end. A simply supported beam of span L is carrying a uniformly distributed load of W per unit length. If the beam is propped at its midpoint, then the prop reaction is equal to 5WL by 8. When a fixed beam of span L is subjected to a central point load W, then the fixing moments are minus WL by 8. A fixed beam of span L is carrying a point load W at a distance A from the support A and at a distance of B from the support B. The fixing moment of A will be 4AB square by L square. A fixed beam AB of length L is loaded with a uniformly distributed load of W per unit length. The support moments are minus WL square by 12. A built-in beam AB of span L is loaded with a gradually varying load from 0 at A to W per unit length at B. The fixing moment A will be WL square by 30. Okay. Now we will continue. Right. Okay. Fixing moment over a simply supported end is 0. When a continuous beam is fixed at the left end, then an imaginary span is taken to the left of the beam. The support moment at the imaginary support is 0. If a continuous beam is fixed at its both ends, the imaginary support is taken on right side only. If one of the span of a continuous beam is subjected to a clockwise couple, then one part of the span is subjected to positive movement and the other part to negative movement. Stiffness factor for a beam fixed at one end and freely supported at the other is called 4EL by L. Stiffness factor for beam simply supported at both ends is 3EL by L. If the end B if the end B of a continuous beam ABC sinks down, then the moment of A will be negative. Torque transmitted by a solid shaft of diameter d when subjected to a shear stress tau is equal to pi by 16 into tau into d cube. A shaft revolving at RPM transmits torque T in kilogram meter. The power developed is 2 pi nt by 60 kilowatts. The polar moment of inertia of a solid shaft of diameter d is pi by 32 into d to the power 4. When a solid shaft is subjected to torsion, the shear stress induced in the shaft at its center is zero. Strain energy is stored in a hollow shaft of external diameter d and internal diameter d when subjected to a shearing stress tau is equal to tau square by 4c into d square plus d square by d. In a leaf spring, maximum bending stress developed in the plates is 3WL by 2NBT square. The maximum deflection at the center of a leaf spring is sigma b L square by 4 ET. When a closely coiled spring is subjected to an axial load, it is said to be under torsion. Okay, so that's all friends for today's class. I think today's class will be helpful for your AE preparation, right? AE and AW preparation. If you are having any doubts, please post in the comments box. Okay, if you have not subscribed our channel, please subscribe our channel. Please like and share our channel. Okay, so thank you very much. Thank you for watching.